All right, well, we'll get started here. So welcome to the VIIRS Near Constant Contrast, or NCC, Enhanced Day-Night Band DNB Visible Imagery teletraining today. I would like to introduce myself. My name is Gerald Torres. I'm here at CIRA and at CSU, and be providing you this training today. And if you guys have any questions throughout the teletraining or afterwards, please don't be shy and just ask away. And so let's get right into it. So first of all, some of the learning objectives that you'll have for this teletraining is that users will acquire understanding of the near constant contrast, or NCC, and its capabilities, be able to demonstrate NCC's primary applications, such as identification of fog and low stratus, the identification of center of extratropical and tropical cyclones, identifying emitted lights from wildfires, and also identifying sea ice. Now, with applications, there's also limitations for this product as well, where users will be able to identify the satellite viewing angles limitations, auroras, the coarse temporal resolution and data latency, along with the lunar cycle and moonlight availability. And then also users will also be able to employ NCC enhancements in AWIPS. And very importantly, how users can find NCC, the actual product, in the local AWIPS systems. So some of the NCC basics. So if people are not aware, the near constant contrast product is a derived product of the day-night band, or DNB, that senses a broad range of light intensities, approximately 8 orders of magnitude in radiant space, and is very sensitive to low levels of light. And that's encapsulating emitted and also reflected light sources. Also note that the DNB is a sensor and also a spectral channel, a part of the VIIRS instrument on board the Sumi National Polar Orbiting Partnership, or SNPP, and also the NOAA 20 satellites, which are currently orbiting the globe and are operational, producing datasets to users. Now, the NCC is a derived product of the day-night band, and it is utilized to mitigate enhancement issues in AWIPS, and it does that by converting or utilizes a sun-moon reflectance model to convert DNB radiance values into pseudo-reflectance-like values. Now, the NCC product is at 750 meter spatial resolution, and is shown here. And this is a nighttime visible scene over the southwestern United States, and it actually looks quite similar to what you would see in the GOES imagery, whether it be GOES 16, GOES 17, or the VIIRS imagery during the daytime. But some of the key features that you see in this particular image is some of the, if I use my cursor here, you can see some of the emitted lights from cities along the Front Range of Colorado. You see some of those emitted lights in New Mexico as well. And then, of course, in some of the other states, you see some of those emitted city lights. Some other features that you can see in this scene are areas of snow cover, which you can see in the western panhandle of Nebraska, some patchy areas in eastern Colorado along the Palmer Divide as well, some patchy areas in Kansas, and then also some snow dendritic patterns that you would see over the high terrain over the Rocky Mountains as well. Additionally, you can also see varying levels of cloud cover. You see a lot of cloud cover inundating the state of Texas there, and then also a lot of portions of the southwestern United States. Now, some of the other just key basics with the near constant contrast, some additional things that you can utilize the product for. First off, we have is an animation over western North Dakota, and in this animation, you see the near constant contrast overlaid by the VIIRS infrared imagery. And what you're seeing in the near constant contrast here is an array of emitted lights, whether it be from cities or towns, and or gas flares, or emitted lights produced from gas flares. Now the question becomes for a user, so you have all these emitted lights, but how can you know where the, say, for lack of better words, the hotspot signature from the gas flare are in the NCC? So what you can do is utilize the NCC with the VIIRS IR, and in the VIIRS IR you'll see hotspots, or the black signatures, and those black signatures will correspond with certain emitted lights throughout western North Dakota, seen here. And you see some of those hotspot signatures just north or south of the Missouri River that you see in the center and bottom center of the animation here. And then what you also see is some emitted lights here on the eastern portion of the image here, which do not correspond with any kind of black hotspots. Another feature that you can, another aspect of the NCC is that you can use this product to identify the reduction of emitted lights, such as inferring where power outages occur. Here's an example over the U.S. territory of Puerto Rico, where you see a reduction of emitted lights after a day or two after Hurricane Irma passed through back in 2017. If you follow my cursor, you see the reduction of emitted lights here in the northeastern portion of the island, and then you also see it via the other islands just to the east, where you see that reduction of emitted lights as well. So you can infer in certain areas where power outages can occur. Another aspect of the NCC is you can utilize the product during the nighttime to observe, overnight convection. Here's an example of severe weather that pretty much is really broad here, going from southern Texas all the way into northeastern Arkansas. And you can see some of the cloud convective tops here. And then what you can also see is these horizontal white streaks here that are indicative of lightning that are embedded within the convection that kind of branch out through southeastern Texas all the way through Arkansas as well. Now these lightning strikes, or lightning signatures, so to speak, are produced due to the time discontinuity between the satellite overpass, which is on the order of seconds, compared to the time duration of a lightning strike, which is on the order of milliseconds. That time discontinuity produces that elongated white streak indicative of lightning. Now, as I transition to some of the primary applications of the near constant contrast product, you can utilize the NCC with a lot of the new datasets, or in complement with a lot of the new datasets from GO16 and GO17, since those datasets are now operational as well for certain types of applications. So first one to highlight is the identification of fog and low stratus with the near constant contrast product over the state of West Virginia. Here in the eastern portion, you see some cloud cover seen distinctly in the nighttime visible imagery. And what you can do in this case with the GO16 night fog product, or fog difference product there, you can assess that these are liquid water clouds hanging around or lingering around the eastern portion of the state. Another aspect of the near constant contrast application is identifying the center of extratropical cyclones. Here's an example of the northeastern U.S. Where you have the NCC overlaid by the GOES 16 10.3 micron. Now in the GOES IR, it may not be as conspicuous of where the center of the storm is, but if you utilize the nighttime visible imagery, the center of the storm is brought out more conspicuously, so you can utilize both in tandem. Also, you can utilize very similar in another case here, a little bit more drastic example, identifying a post-tropical cyclone, where in the IR it's not clear at all where the center of the storm is. However, if you utilize the nighttime visible imagery, it pops out pretty easily. So this is just more of a drastic example of identifying the center of, in this case, a post-tropical storm. Also, very similar to the gas flare example, you can utilize the near constant contrast in identifying the emitted lights from wildfires. And here's an example of the NCC overlaid by the GOES 17 3.9. Now with the NCC, you can see all these, pretty much an array of emitted lights that kind of correspond or that sort of align with a lot of the interstates, and then also in other areas as well. But then you also have emitted lights from the wildfire. Now you as a user, how can you differentiate between the two? Between what is emitted light from fire to emitted light from a city. And that's where the IR comes in from the GOES 17, where you can identify where the hotspot is, in this case in red, and that corresponds with certain emitted lights in the center of the scene here. And this is of the 243 fire in central Washington earlier this year. Also, you can identify sea ice with the nighttime visible imagery. Here's an example of the NCC compared to the VIIRS infrared imagery at 11.45 micron. Now on the 11.45 micron here, especially in the northeastern portion of the scene, in the infrared you can see to a degree some of the sea ice here. However, some of the sea ice that's closer to the Alaska state borderline here, it's not clear where the sea ice is. However, with the nighttime visible imagery, that sea ice pops out pretty clearly. And now I'll transition to some of the limitations of the NCC product. First one is the satellite viewing angles that produce the satellite viewing angles from the series of different polar beam SWATs in the NCC imagery. And what you're seeing here is a shift in your emitted lights from one SWAT to another. Now this is a known terrain correction issue in AWIPS, and the plan is that this terrain correction issue will be fixed. It's not going to be in the near term, but more in the long term. By the time that JPSS-2, or what will be known as NOAA 21, is launched within the next, I believe, 2 to 3 years. But just know that this is a known issue at high elevation areas for certain WFOs. Also, another limitation, there are also what you can see in the imagery as auroras, which are very broad in aerial extent and elongated white streaks that are produced from the aurora. Now these auroras are so bright that they actually obscure some of the surface features that you may be interested in seeing, such as emitted lights from wildfires, for example, or in this case, just northwest of Alaska here, you see an elongated bright white streak from the aurora. However, you can't see any of the leads from the sea ice or any of the cracks or crevices beneath that. So, which could help you with helping out your fishing or shipping industry partners. And then also some other limitations are, well, first of all, the temporal resolution. So you get 2 data sets per polar orbiting satellites. So one in the early morning hours and also one in the early afternoon hours. But then you also have the issue of, or limitation of the data latency. So the time of the satellite overpass to when it gets into your AWIPS terminal. Now, if you have SMPP NCC data, it should be, and you get your data sets from the SBN, I believe your particular data latencies should be between an hour to an hour and a half or so. Now, if you have NOAA 20 datasets from the SBN, I believe it's a little bit lower latency, maybe approximately an hour or so. However, if you have access to datasets via the direct broadcast antennas, then you can get your datasets at a significantly lower latency at approximately, I believe, 30 minutes or so. So just be aware of that. And then my last limitation I wanted to highlight with the NCC is the moonlight availability and the lunar cycle. So this is an animation over the state of Washington, and it goes from the new moon phase of the lunar cycle, which you see with the moon phase in the bottom left corner there, to the new moon phase over a particular month. And what you're seeing here is how your imagery is impacted by based on the moon phase, and when it is above, when the moon is above the horizon. And essentially, during the new moon phase, your atmospheric features or your cloud cover becomes more dim and fuzzy, and certain features don't become as apparent. However, during the full moon phase, as this animation is getting closer to, your imagery becomes more crisp and detailed and clear. So just be aware of the limitations with the lunar phase and the moonlight availability throughout the month. And this, especially during the new moon phase, as I just mentioned to you, there's also NCC enhancements in AWIPS to help bring out certain atmospheric features more than others. And in AWIPS, you can customize your particular color tables or scales to help bring out certain features. And I just want to note before I go through my animations, at the bottom of this page, there's a few links here where you can go to a particular quick guide or more supplemental information where you as a user can go through the documentation to that will help you with the proper steps to help produce certain enhancements in your AWIPS, and also provides you additional information. But here's just an example or here's a few examples. Here's the first one here is over the state of Colorado, and as I'm toggling back and forth, I'm utilizing the default 0 to 1 scale, which over the state of Colorado, where you can't really see, you see some areas of cloud cover within the states. However, if you utilize the 0 to 0.5 scale, those features can be brought out. Another example is in identifying smoke at night from, like, say, wildfires. Here's a similar example. You have the default 0 to 1 scale, then utilizing the 0 to 0.5. And if I toggle back and forth, you can see more of the milky grayish areas of some of the smoke, especially in northern Wyoming, if you follow my cursor here, and also in Montana. These were actually fires, these were actually smoke that were produced from fires in Alberta, and that advected to the southeast from Alberta into the Rocky Mountains within the CONUS. And these were fires that happened back in August of 2018. And then for a more recent example, my last example here highlights, I know it's not CONUS related, but it's actually from Eastern Australia. There was, if you've been paying attention to the news the last few months, the eastern portion of the continent has been inundated with a lot of fires. And here's just an example of a fire just northwest of Sydney. And the point here is utilizing that enhancement from the default 0 to 1 to the 0 to 0.5 enhancements, where your smoke becomes accentuated. However, just note that if you accentuate your smoke there, you'll also have a consequence in the saturation of your city lights, or your emitter lights from the fire will saturate. So just know of the pros and cons of different enhancements. So essentially, different enhancements will bring out certain features more than others. And then as I transition to almost the end of this teletraining, here's just one of my last slides here of how you as a user can find the NCC product in AWIPS. Now note my version here, or my screenshot here, is from the 18.1.1 version. My version is a little bit more out of date than I assume you guys at your WFO are in the 19.1 or 2 versions. So, but point is, to find your NCC product, you just go up to the satellite tab there, scroll down to SMPP node 20, go to SMPP, in this case SMPP CONUS, and then to 0.7 micron, your constant contrast. And then I will go to my summary slide here. You can read my summary there, but I wanted to highlight at the bottom of this page some of the resources that you can access as users. There's a lot of training out there for the NCC product. The first one here is a visit training module, I believe, of the introduction to the NCC and the D&B VIIRS imagery and AWIPS. Kind of gives you a little bit more detail of the differences between the NCC and the D&B. The next one there highlights the VIIRS day-night band training module that's a part of the satellite foundational course for JPSS. And then also you have a quick guide from the NCC, that just a 1 to 2 pager highlighting the products, highlighting the pretty much the product applications, the limitations, and case examples of the NCC. Essentially what I showed you here, but just in a quick 1 to 2 pager. And then we also have a visit satellite chat that helps with, or that explores more of identifying smoke at night via different satellite data sets. But with that, I thank you for your time, and if you have any questions, whether that be here or later, just ask away. But there's my contact information, and if you have any questions, please ask away.